Today we're looking at the effect of temperature on the process of dissolving. On Friday, I made some chocolate milk, and I stirred one mixture of chocolate milk and left the other alone, and we noticed that particle size had an effect on the process of dissolving, and stirring had an effect on the process of dissolving. Stirring the chocolate milk on Friday caused the mix to dissolve faster in the one that was stirred than it did in the one that was not stirred. Today we're investigating the effect of temperature on the process of dissolving. So I'm going to make a cup of chocolate milk and a cup of hot chocolate using my pot on the stove. So I'm just going to turn the heat on, and I'm going to add the milk to the pot, and I'm going to allow the stove to heat up the milk. I'm going to add 1 spoon of chocolate milk mix to the cold milk and 1 to the milk on the stove as it heats up. And I'm just using the spoon not so much to stir the particles, but to make sure that the milk itself doesn't burn. So we can see that right away when I added the chocolate milk mix to the cold milk, it's just sitting on top. Here on the stove, it's starting to break apart a little bit. You can see the electricity of the stove has changed into light and heat. Slide that back over onto the burner so that the milk warms up to make our hot chocolate. See what's going over here? Not much. I'm just going to give this just a gentle stir. Again, not so much to break up the particles, but I just want to make sure the milk doesn't burn. You can see on the spoon there are some particles of milk, undissolved chocolate on the spoon. Today you'll be investigating the effect of temperature on particle size by observing table salt. We call it table salt because it's the kind of salt that you would use on your kitchen table. Oop, mine's almost empty. I'm going to have to refill that. So here's a container of table salt. It says Morton salt. That's what we put into the container that we use with our meal. You'll be investigating the effect of temperature change on the process of dissolving 2 samples of salt and water, 1 warm and 1 cool. You're not going to stir because you don't have to worry about your liquid burning on the stove. I'm doing that because mine might burn. If we go back over here to the cold milk, nothing has changed. All of the mix has settled to the bottom. It has not dissolved. Over here, we can see that my spoon is coming out cleaner. The mix has dissolved. I'm going to keep that stirring just so we don't burn that milk. But you can see the difference just by looking in there. There's no particles of chocolate left. Over here, you can still see those undissolved particles of chocolate sitting on top of the milk. So I know this isn't quite hot enough yet to drink. It's not really hot chocolate, it's going to be warm chocolate. But let's pour that back into the container. There, see, there's a couple of chunks of chocolate on the bottom that have not dissolved. Let's turn the stove off and be safe. Now when I compare the two side by side, here's the particles of chocolate on the bottom, undissolved. Here's the particles of chocolate in the chocolate milk, completely dissolved in there. That's going to be delicious.